Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just
Converter is used to connect to the onboard network of the car various devices that operate from the voltage of 220 volts. For example, a powerful amplifier or laptop. Converters that are sold in stores cannot always give the necessary power. Therefore, many drivers who understand electronics make a car inverter 12-220V with their own hands. Devices that make their own hands better suited to power specific devices, and also cost less than serious units sold in stores. How the inverter works. The basis of an automotive inverter is a pulse width modulated PWM generator. This device operates from a 12-volt battery and produces rectangular pulses, meander, with a variable duty cycle, ratio of the time of presence-absence of voltage. When the duty cycle is equal to 1, the inverter provides maximum current. The lower the duty cycle, the lower the current. At the same time, the output voltage always corresponds to the value of 220 volts. The frequency of operation of the generator is from 50 kHz to 5 MHz, depending on the circuit and parts. The transformation of high-frequency voltage into a low-frequency voltage, 50 Hz, occurs by smoothing the meander in the oscillating circuit formed by the transformer and capacitor, as well as filtering harmonics. After all, the PWM generator not only creates an alternating voltage of 220 volts with high frequency, but thanks to the changing change of the frequency change modulates the output voltage with a sinusoidal signal with a frequency of 50 Hz. When the inverter is operating without load, the PWM generator signal frequency is minimum and the output voltage is 220V. Connecting a load causes the current to increase and the output voltage to drop below 220V. The feedback system compares the output voltage with the specified standard. It then gives the generator a signal that increases the pulse width. Thanks to this, the output power increases and the voltage rises. When the load is disconnected, the output voltage rises above 220 volts. The feedback system then reduces the pulse width until the voltage returns to normal. Changing the pulse width and output current increases the load on the battery. Therefore, its voltage often drops below 12 volts. In this case, the feedback circuit further increases the squirrel speed, up to 1. Often the converter, made with their own hands, which does not provide feedback, reacts to the connection to a discharged battery by reducing the output voltage. Therefore, they are not very suitable for powering an amplifier or laptop, but they will be quite able to ensure the functioning of devices with a reactive load, handheld power tools, lamps, boilers. If the converter is needed to power an amplifier, receiver, TV, or laptop, then you can't do without feedback. Some complication of the scheme is compensated by the fact that the feedback compensates for voltage fluctuations. This will ensure the normal operation of the amplifier or other devices. Circuit selection. In the Internet there is a huge number of schemes of devices that convert the energy of a car battery, 12 volts, into alternating voltage of 220 volts and are suitable for making with your own hands. Therefore, it is necessary to choose a scheme focusing on access to the element base and experience in working with such devices. If there is a radio parts store near you, you can ask them what controllers and power transistors are most available and already under them to pick up the most suitable scheme. You can also use those parts that are in any computer power supply. From there you can take controller, PWM generator, ferrite ring for the transformer, power transistors, capacitors, resistors, filter chokes. If you are not sure that you can make a complex device with feedback with your own hands, collect a 12-220-volt inverter based on a multivibrator for 50 Hz. The transformer for it can be removed from an old transistorized TV set or uninterruptible power supply, UPS. Such an inverter takes much more space than a high-frequency device. However, it is easier to set up, and parts for it are easier to find. Connecting and operating the inverter. Car inverter from 12 to 220 volts with a power of more than 120 watts consumes a current of more than 10 amperes. Therefore, it is undesirable to connect it to the standard cigarette lighter or ignition switch. This is especially true for modern cars. After all, a stronger current will cause the fuse to burn out, and installing a plug instead of it may end up burning the wiring. Therefore, an inverter with a power of more than 120 watts must be connected to the battery through a fuse and a switch with a relay. To do this, you will have to lay a separate wire with your own hands and install a 220-volt socket somewhere. It can be put as under the front panel on the passenger side, and in the trunk. After all, it is very inconvenient every time to open the hood, connect the inverter to the battery and drag the wire into the car interior. It is easier to press the button that turns on the relay and the inverter from 12 to 220 volts will start working. Parasitic harmonics. Any 12-volt battery-powered inverter produces a huge number of harmonics in addition to the 50 Hz voltage. Most of them are multiples of the frequency of the PWM generator. These harmonics appear due to the effect of the meander on the oscillating circuit formed by the transformer and capacitor. If the level of harmonics is high, they will affect the operation of an amplifier, CD player or receiver connected to the car's on-board network, 12 volts, filling their signal with noise, crackling, growling and other extraneous sounds. However, harmonics will have no effect on the operation of a laptop, lamp or handheld power tool. To reduce the influence of parasitic harmonics, the 220-volt inverter converter is covered with a thin tin screen and connected to the minus terminal of the battery. You can also fight harmonics by increasing the frequency of the PWM generator, in addition to connecting with their own hands additional chokes in the circuit of input and output voltage. A large inductance does not interfere with the passage of direct current. However, for alternating current, a different rule applies. The higher the frequency or inductance, the higher the reactance. Given that the frequency of parasitic harmonics is much higher than the frequency of operation of the generator, a properly selected choke reduces their intensity tenfold. In conclusion, creating your own car inverter to convert 12 volts to 220 volts can be a rewarding and practical project. By following the steps outlined in this video, you can harness your DIY skills to build a device that meets your power needs on the go. Remember to prioritize safety throughout the process and ensure all connections are secure. With a little patience and attention to detail, you'll have a functional inverter that can power your devices wherever you are. Thank you for watching, and happy building!